Robots are going to be able to do more manufacturing jobs than they're capable of, but at the same time they eliminate jobs, they're going to create new ones. On today's show, we are joined by 3 experts that explain how robots will make companies cost competitive in global markets. And now, here's your host, John McElroy.
I want to thank you all for joining us on Autoline this week. Today's discussion is all about robotics. Are they going to steal your job, or are they going to lead to a much more productive future? Well, I've got 3 experts to talk all about that, including Jeff Burnstein. He's the president of the Robotic Industries Association. Mike Cicco is the president and CEO of FANUC America Corporation. That's a robot maker. And Marty Linn is the manager for advanced automation and principal robotics engineer for General Motors. I want to thank all 3 of you for joining us here today.
Thank you. Thanks for having us.
Yeah, Jeff, why don't I start it out to you? Big fear out there amongst the public that robots are going to take all of our jobs. How do you answer that?
Well, we answer it by saying that the real threat to jobs is the inability to compete. If you can't compete, there are no jobs. Robots are actually saving and creating jobs in the U.S., and if you look at it over a 20-year period, we found that every time robot sales went up, unemployment went down. The opposite, when robot sales go down, unemployment goes up. So that's been the history. We think that's the future as well.
Mike, how do you create jobs with robots? I would think that a robot's going into a plant to replace workers.
Yeah, sure. That's a great question. You know, when you think about manufacturing, you think about productivity, and as these manufacturers need to create more things, sometimes the robots assisting the people in terms of helping them make the things enables those end customers to be able to produce more things, and then you need more people to do all the people things that surround all the things that can be automated. So when you tend to make more things, there's still a lot of people that need to be employed, and those people grow as we're able to produce and make more things.
And Marty, how do you answer that same question too?
Well, I mean, we're always trying to be more competitive. We're trying to make our workplace safer. We're trying to build more products for our customers. And to do that using the latest technologies, we're using robots in ways that are going to help people really address what we call the 3Ds, the dull, the difficult, and dirty types of jobs. Those are really the types of tasks that we apply robots to. And interestingly, you know, between 2012 and 2016, we added about 25,000 jobs to General Motors employment roles at the same time that we added about 10,000 more robots. So, you know, we definitely view that as you use more robots, we get more employment. We're able to build more products.
And yet the public believes that robots are going to take over everybody's job. Why do you suppose they've got that impression?
Well, I think a segment of the public believes that.
Yep.
The media often reports studies that come out, and I'll give you a great example. There was a McKinsey study that came out last year saying 800 million jobs could be lost globally due to robotics and automation. We had the authors of the study at our annual meeting in Orlando, and when the discussion came up, they said as many as 890 million new jobs could be created. In other words, a net gain of 90 million jobs. How many times have you seen a headline that said that?
Never.
There you go.
I think it's also a lot about the education of the workforce, the manufacturing workforce. There was just an article today in the Wall Street Journal that talked about how what the robots are actually doing to the workforce are creating new jobs, new, very rewarding, very intellectual jobs that's creating really the next generation of the manufacturing workforce, which is working with the robots. And which is a lot better than some of the jobs, those dull, dirty, dangerous jobs that Marty mentioned that are in there today.
What kind of new jobs are they creating?
Well, if you think about what you need to make a robot work in an assembly line in automotive or really in any industry, you need programmers. So you need people that can program the robots. Those are typically people might have an engineering degree or even a 2-year technical degree, all the way to the maintenance folks that need to service and maintain the robots. And in this case, we're creating really high-paying, very highly skilled jobs of kids that are coming right out of high school out onto the manufacturing floor. So those types of work, that type of work that's in manufacturing today is really, really turning turning the industry around.
But the key is really being able to continue to do manufacturing in our country. I mean, you really, if you can build, if you can manufacture, that's what we're talking about, is using robots to be more competitive, to be able to continue to build products. Those are the types of jobs that you're able to look forward to.
Some people are worried about robots stealing jobs, as we've just talked about. Others are saying maybe this could lead to onshoring of jobs, i.e. jobs that have been outsourced out of the country could be brought back. How do you guys see that?
Yeah, really, it's not could lead to, it is leading to. It's been happening for quite some time now, where manufacturers who have left to go into low-wage nations are coming back. It has to do with transportation costs. It has to do with the speed in which people need things to market. Where in manufacturing today, people need products at the speed of business, and putting something on a boat and letting it sit on the ocean for a month, and a lot of times takes too long. So it's not that it's going to happen; it is happening and has been happening for quite some time now.
And it's been enabled by automation. So you see companies like Foxconn, for instance, from China, coming to open up in Wisconsin. Couldn't do it if they couldn't automate it.
That's a great point. I got to believe, too, that the nature of robots is changing. I mean, decades ago, they were these big, bulky, hydraulically operated, i.e. they leaked a lot of hydraulic fluid kind of robots. These days, I see little robots, cobots, working hand in glove or side by side with human beings. You know, are you guys using them at GM?
Absolutely. You know, the collaborative robots, what you referred to as a cobot, the collaborative robots really have allowed us to be able to look at the work that our workers are doing and try to address the dull, the dirty, the dangerous types of tasks, help them out from an ergonomic perspective by getting the operators that in the work that they do really well, get the robot close to them and let it be a tool or a helper for the operators.
Yeah, we've seen in manufacturing, there will always be things that a person is best to do. That will always happen. And historically, you would separate robots and workers by either a fence or a cage or a lot of space.
Because the robots were so dangerous.
That's right. And as technology has advanced, we make a line of collaborative robots. A lot of others make lines of collaborative robots. And it has enabled really the robots and the people to share that workspace, so that the people do what the people are good at, the automation does what the automation is good at, and you're able to really collapse that down and do it into a very small space, which is important for the manufacturing business.
Really optimize the work that needs to be done between the person and the machine.
Right. Focus on the task.
You know, another thing that we've seen is that the advent of collaborative robots has opened up small and medium-sized companies to say, hey, mate, maybe we can automate using robotics. Because in the past, people thought it was only for General Motors and big companies. It was too costly, too complex. But small and medium-sized companies are looking at robotics now, in part because of collaborative robots. Sometimes it's the right choice. Sometimes a more traditional robot is the right choice. But remember, small and medium-sized companies account for the backbone of manufacturing in the U.S. We need to reach these companies.
That's true, Jeff. Yeah, even in our business, you know, getting close to probably about 50% of our business does go into those areas, into those small to medium-sized businesses. So getting the robots that are easy to deploy, that are easy to use, that small to medium-sized business owners can jump in and automate, is going to be that backbone. It's gonna enable that. It's a massive enabler for our industry.
Isn't a key in this part of the discussion that these cobots are a lot less expensive than the bigger, more traditional kind of robots that had to be fenced off with all kinds of safety things? I hear that some cobots can be on the line, programmed and ready to go for about $45,000. Is that in the ballpark of where they are? You know,
I wouldn't say that the robots themselves are cheaper than their equivalents. Certainly a smaller robot costs less than a bigger robot, but a small collaborative robot or a small non-collaborative robot, cost-wise, is about the same. You start to get into some of the cost savings when it comes to ease of use. So with a cobot, a lot of times you don't need some fencing, so there's some cost savings there. Or if it's easy enough to use, you might not need a lot of programming, so there's some cost savings there. So the actual equipment itself may not be that much costly, but the faster you can deploy something, the cheaper it's going to be for sure.
And we really look at the capabilities. What capability in your actual manufacturing process does the collaborative robot give you? You know, the fact that you can put that robot right next to a person really increases the capabilities, reduces your floor space, allows you to do more work in the same area.
What are the good applications for cobots then? You mentioned the 3 Ds, you know, dirty, dangerous, and drudgery. What are the cobots best for?
Anything that is ergonomically challenging for people, that is very repetitive, that is again, dirty and difficult for people to do, collaborative robots are potentially a good solution for that.
Yeah, we've seen a lot of applications for that. You know, handling things that a person worker wouldn't necessarily want to because of ergonomic reasons. We've also find that collaborative applications where you have specific collaborative robots, those are special robots, but then what we're also getting into is more collaborative applications where you might take a big robot, one of those big dangerous robots, but you can put some safety around it where you can actually interface with some of those big robots as well and do collaborative things with those as well. It's really opening it up to a lot of different size robots.
The other area that it's opened up a lot is assembly. So in China, for instance, electronics assembly is the big market, and collaborative robots have made their mark there already.
Yeah, that's true, Jeff. If you can think about putting a cell phone together and how the intricate task of maybe routing cables through a phone would be best done by a human operator, but the preciseness of a robot, if you ever look at your phone and see how small the screws actually are holding your phone together, you can think of where the preciseness of a robot would be beneficial. But as Jeff mentioned, there's a lot of tasks like routing cables, maybe doing some level of visual inspection, doing some of the software testing that is all best done by a person.
Yeah, we have a lot of applications for doing inspection where you have a very complex part with a whole bunch of connectors, for example, and we can program a robot carrying a vision camera to go and inspect each one of those so that, you know, it's very repetitive and it's very intricate how the robot goes and actually positions a sensor. We're able to do that to improve the quality of our products that we're shipping to our customers.
Mike, you mentioned what robots are good at doing. What are humans good at doing? When do you say, nah, we don't want to put a robot here? What makes humans better than robots? What kind of applications?
Well, it's tough. You're asking the robot guy what makes humans better at things, but no, it's there's a lot of things that people are very, very good at. It's amazing when you've been in the robotics business for a long time, you actually see the beauty of the human mind and the ergonomics of your hands. Because if you just think about your hands in general, that's a key part of trying to automate something is adding a hand to the end of a robot and the limitations that you come out with. So we can have suction cups and we can have grippers, but the dexterity of the human hands is something that will always lead to better performance from there. So, you know, routing cables through even, you know, especially on the assembly line, in general assembly, putting the components on the inside of a moving line, routing the cables through, putting the headliner in, things that are flexible and hard to manage are things that a human's good at. Also, there's the sense of sight of a person. Although with artificial intelligence, the sight of a robot is getting better and better. We're doing some things, very unique things in that field. But still, the perception of a person is also very good when it comes to inspection.
I was going to say that the robot is also one part of the system. People are really good at designing systems and figuring out what goes where, how to make the system run effectively. And I think that the U.S. is blessed with a tremendous amount of great system integrators.
Mm-hmm.
Yeah, that goes back to the employment standpoint, whereas it's not just on the assembly line where we're talking about adding more people, that all of this automation requires a massive workforce of people that design the systems, not just the robots, but the entire systems that's creating. It has created really a whole other industry of systems workers.
How do you avoid over-automating? Marty, I know, Tesla's been in the news recently. Elon Musk has come out and said we put too many robots in. I know GM went through kind of a similar situation, but that was several decades ago, back in the 1980s. How do you draw the line and make sure that you're not over-automating?
Well, you're absolutely right. Through the early 80s, we tried to automate a lot of different things, And some were successful, some not so successful. And what happens through those experiences, you have to learn and get better as an organization. So, you know, our approach to doing automation is to automate those things and make sure that as you're going through the automation process, you have all the checks and balances. I mean, from doing the business case and understanding what the trade-offs are and really understanding the full scope of the application that you're trying to automate.
But I got to believe, too, it's not getting overly excited, because I got to believe it's exciting to work with robots and bring all that into a plant.
It is exciting every day, absolutely. We all have great jobs working with the latest technology, really to be able to, in my case, building cars and trucks that are just fantastic and being able to deliver those to our customers and being able to solve engineering problems. I mean, at the end, I'm an engineer, so I like to solve engineering problems.
Yeah, I think Marty put it best. We're a team of problem solvers is what we do. That's what we do. I tend to not think you can over-automate. I think, I'm not sure you can over-automate, but you have to do it in the right way. We have a team, we have hundreds of engineers at our company that are just there to answer that question about solving a problem. Is there a problem? Can we solve it with automation or robotics? And if that answer is no, then it gets put on the shelf, and we're gonna answer it later. So I think that's really the key is to ask all the right questions in the first place, get all the right answers, figure out what we can automate, what we can't automate, and the things that we can't, we'll try and figure out later.
And not automating just to automate, not for the sake of automating. Right. We really want to solve problems.
Yeah.
Right.
Jeff, there's this talk, and the three of you know this, there's talk in manufacturing circles now of what they call Industry 4.0, where every piece of equipment in a plant is on the internet. The Internet of Things comes to manufacturing.
Right.
Talk a little bit about that, where you see it coming from your association standpoint and the role that robotics plays in this.
Well, I think it's been beneficial, and one of the reasons is in predictive maintenance, for instance, where the robot is signaling that it's about to fail. If it is repaired before it fails, you eliminate the downtime. So I think it's been a big enabler. Industry 4.0 is, you know, kind of a buzzword, but the idea of connected devices on the factory is a reality. And I think it's helping companies gain more insight into their process and have better outcomes.
For us, it's really being able to deliver the best products to our customers. We want to make sure that the quality is ensured in those products. So by hooking up all those devices, and by the way, we've worked with FANUC over the last 3 or 4 years to hook up over 10,000 different robots so that we're monitoring them every single day. For every job, we're looking and making sure that the robots are doing what they're supposed to do. But we want to do that for the entire factory, really to be able to, again, to ensure the quality that's coming out of our plants.
Yeah, Marty, like you said, when you talk about Industry 4.0, it really is all about data. The robots produce data, the manufacturing lines produce data, and Industry 4.0 is about collecting that data and doing something with it. With the robots, what FANUC has done, as Marty mentioned, we can collect that data, and we have a lot of really smart people back at our office that are analyzing. We've written analytics about that data to automatically determine whether or not the robots are healthy or not. We call it zero downtime, because we want to prevent downtime in the factory. And so by doing that, by collecting that data, we're able to analyze it, we're able to produce and predict proper analytics. For the future, just think about a factory floor and how much data is actually produced, really not just from the robots, but from the conveyors to the vehicles that we're producing, to the sensors that are on every single part of the line, to all the vision cameras that are out there. It's a tremendous amount of data, and so we're just starting to scratch the surface, even with over 10,000 robots connected and talking with our zero downtime product. We're just starting to scratch the surface with Industry 4.0.
Marty, what are you learning from all this data? What are you collecting? What are you learning? What are you doing with it?
We're trying to collect as much as possible, but kind of like with your email system, you know, you get all these emails every day, and what do you do with them? Some of them are really interesting and very valuable to you, like, you know, your notice that you got to go have a doctor's annual checkup, and some not so interesting, like, you know, you can get this money from Africa, right? All they got to do is give you an account number so that they can transfer it to you. The key is being able to take data and make sense from a system perspective and relate it back to your overall process and product, the product quality and the process quality, how you're actually building and what it means to your product. So you have to, the smart factory, the Industry 4.0 people have to understand what they're producing. They're really the people that have to make sense of all that. But in conjunction with the equipment suppliers, you have to be able to have those capabilities to capture the data that Mike's talking about. I mean, you have to be able to get the right data at the right time because it's just so much of it.
Right. Mm-hmm. Jeff, you had mentioned that now small and medium-sized manufacturing companies are getting into it. Are they doing this Industry 4.0? Are they collecting this data, or is it just big corporations like General Motors doing it?
You know, I think some are, but I think many are overwhelmed, frankly, by Industry 4.0, artificial intelligence, big data. I think we're running into some of that with small and medium-sized companies saying, well, maybe we could do this. We don't know how to get started. We need help. Mm-hmm. So we're looking into those things to see what we can do as an association to help some of those small and medium-sized companies.
Yeah, and some of the priorities are a little bit different when you get into a small to medium-sized business. For example, if I have a robot that takes the GM Arlington truck line down, we're costing GM millions of dollars by doing that. Whereas if one of our products fails, if one of our product fails at a small to medium-sized business, say in the state of Wisconsin or Michigan or something like that, they might be able to tolerate a little bit more downtime than a large automotive OEM would. So the data is still important. We can just use it in different ways. So instead of using the data to maybe predict a failure before it happens, what if we could use the data to maybe improve their process, where we look at we can remotely look at the data and say, we think we can improve your productivity by 20% because from what we're seeing from the data, you have 20 minutes of downtime every hour where the robot's not functioning properly because of something. So we're trying to still take the data, but we might use it in different ways as we get to small to medium-sized businesses. But making sure that data is secure and protected is always, that's going to be the same for really all customers.
But John, as Mike was talking about, it's really understanding how that data relates to your overall process and understanding how you can make your process better, be more efficient, basically be more competitive.
Right. Yeah.
How about using artificial intelligence along these lines? Both for monitoring the robots, analyzing the data, and maybe seeing things that even the best human analysts can't figure out. Is that being used?
Yeah, from my perspective, that comes down to making the robots easier to use, using artificial intelligence. In order to get an automated cell, really, whether it contains robots or not, anything on a manufacturing floor that's automated in some way, you need somebody that knows how to program all of that. You need it, whether it's a systems engineer, controls engineer, software engineer, that is capable of programming that whole thing. And people with those skills are in high demand right now, and there's not as many of them out there as we'd like. We're working on it. We're trying to train as many and educate as many people as we can. But what artificial intelligence, I think, is going to bring is a level of taking complex tasks and even automating some of those complex tasks. You think of a bin full of random parts. We've been able to use artificial intelligence to where the robot, through a trial and error and a deep learning process, is able to teach itself how to empty a bin full of parts. And that's going to bring that automation to the factory floor a lot faster than it would ordinarily.
That's an amazing example that you're giving right there. It's extraordinarily complicated for human beings to program robots to be able to pull out all different kinds of parts from a bin. You're saying with artificial intelligence, it can sort of learn it on its own.
It's true. It's not to market yet, but stay tuned. It's coming. We're getting pretty close to bringing it to market now.
I think the big impact is being able to deal with the scope of the amount of data that we're talking about for an Industry 4.0 scenario. You have gigabytes of data from across a single plant, let alone if you start looking across various factories. And the artificial intelligence, being able to relate individual pieces of data and events that happen on your floor, that's something that's very, very difficult for a person to do. I think that's probably where we will see the first impacts of using artificial intelligence on the plant floor.
Eliminating problems, getting more uptime,
Absolutely.
better throughput, all that sort of thing.
Right. Yeah. Imagine if GM's bringing a plant online in Texas, And through artificial intelligence, the robots learned how to do a task. And instead of sending another crew to Indiana to program the next plant, all of that data gets transferred directly to the plant, and the robots are given the information from the other robots so that bringing them online happens a lot faster. That way we can start up plants faster, we can get things online faster, and start producing parts faster, which is really the end goal.
Mm-hmm. Jeff, you see this getting spread throughout your members?
Oh yeah, absolutely. I mean, this artificial intelligence trend has a lot of life left. I mean, so some of these things are buzzwords. So Industry 4.0 today might be 5.0 next week. Artificial intelligence isn't going anywhere for a long time.
Yeah, I've heard somebody already coined the phrase Industry X.0, so you don't have to worry about which number goes in there.
Right.
But you seem to have hit on something, too, that if someone can figure out how to simplify this for small and medium-sized companies, maybe some sort of turnkey package, this could really take off.
Yeah, you know, data sets is the big thing. So big companies have a lot of data, and they can take advantage of it. Small and medium-sized companies, maybe less so. So we're trying to figure out, is there some way that companies who have a lot of data would be able to somehow share it with smaller companies so that they could get more insight into their process.
Is that making any headway?
Well, I think we're starting to see people at least talking about it. Yeah. I mean, data is really important. Your data is really valuable, so it's not easy to get people to, but there might be some, you know, common things that people would be willing to share.
We're starting to see a pretty strong connection between this area, the Detroit area, and the Silicon Valley area. We're opening up a new technology center in the Silicon Valley. I mean, it's been there for a while, but we're bringing on more people. We're bringing on more talent in that area. That there's such a strong connection now between the Silicon Valley software folks and the Detroit area with the strong manufacturing here. It's pretty incredible what's happening.
Real good. With that, we're going to have to wrap this up. Very interesting discussion. I feel a whole lot better about robots these days after talking with you guys. Jeff Burnstein from the Robotic Industries Association, Mike Cicco from FANUC America, Marty Linn from General Motors. Thank you guys. Really appreciate this discussion.
Thank you, John.
It's great.
Thank you for having tuned in.